Welcome to PreCalc 12, Chapter 6.3. And radian measures. Recall that we can convert between degrees and radians. The degrees is equal to 180 times the radian measure divided by pi. And the radian measure is equal to pi times the degree measure divided by 180. Try these two problems. Press pause, and then when you're done, unpause and look at the answers. So this is pi times 1 over 180. And this is just pi over 180 radians. And here we have negative 3 pi over 2. And this is 180 over pi times negative 3 pi over 2. And this is negative 270 degrees. Frequently, we're asked to find all coterminal angles. So, to find all the coterminal angles of pi over 4, we just write pi over 4 plus 2 pi n element z. And remember, 2 pi is once around. As you recall, pi over 4 is 45 degrees. So another solution would be 45 degrees plus 360 degrees times n from the set of integers. Okay, find all coterminal angles with 5 pi over 4. 5 pi over 4 plus 2 pi n element z. While I'm thinking about it, it would be good to do 3 pi. 3 pi is not a principal angle, so you would want to convert this to a principal angle. So this is 2 pi. So we would have pi plus 2 pi n element z. Okay, so that is finding all coterminal angles of 3 pi. Put it into the principal angle, and then do the general form. Here's a list of our special angles. 0, 30, 45, 60, 90. Okay, and you should know the trig ratios for all of them. Since this is a unit circle, we have the ratios right here. Root 3 over 2 is x, which is cosine, 1/2, which is the y, and that's sine, and so on. Notice that the rest of them are all the same except for the sines. And 30 is the reference angle for 150, 45 is the reference angle for 135, 60 is the reference angle for 120. And similarly for the other quadrants. So that's why we only have to memorize this quadrant. The rest of the special angles are based off of these reference angles. Okay, determine the exact trig ratios of angles. And you can use the modulus function to do this. This is not the same as the remainder function. And that's because they differ when the angles are negative. And a good analogy is when you're using a clock. When we subtract 3 hours from 1 o'clock, we don't have negative 2 o'clock. We get 10 o'clock. And with the clock, we have modulus 12. So, negative 8 over 3 pi modulus 2 pi, we get 4 pi over 3. And how do we calculate modulus? Okay, so we have negative 8, and we have to put 2 in the denominator. This equals negative 1 and 2/6, which is negative 1 and 1/3. Now we have to multiply 2 by negative 1/3 plus 1 in brackets, and we get 4 over 3. This is 2/3 times 2, and we get 4 over 3. So this becomes 4 pi over 3. So we leave the pi out of this temporary calculation. Okay, and you might be able to say, okay, negative 8 pi over 3, and you can figure out that this is 4 pi over 3. Negative 8 pi over 3 actually goes all the way around and to there. But what if you have a really big number? Well, this is actually 4 pi over 3. We take 148 divided by 2 times 3, so we get 24 and 2/3. So we take 2 times 2 over 3, and we get 4/3. And again, we get 4 pi over 3. Okay, you may not want to do these calculations, and I don't blame you. The other way of doing it is just keep subtracting 2 pi until you get to 4 pi over 3. Here we can add 2 pi until we get 4 over 3. So you would have to add 2 pi twice. Here you would have to subtract 2 pi quite a few times. We can do this on our calculator. I've put this program up here as a demonstration that you won't get this answer because it's negative. You'd get this answer because it's positive. You need the mod function. So let's enter this program on our calculator. We go program. You will have to go new. You'll enter mod as your program name. I'm just going to edit mine. To get the input function, you need to press program. Then it's under I/O, so you need to go right. And input is the first one. So you can hit enter or you can press 1. And now you're entering alphanumerics, so it's best to lock it. This was second alpha. The quotes is the plus sign. B is the apps button. And then you need the space, and that's the 0 button. And you need quotes again, so the plus. And now you need a comma. That's not alpha, so you need to press alpha to get out of alpha lock. And you can tell because now it's just flashing rather than flashing A. And then comma. And B is alpha again, but we don't need to alpha lock that, so we'll just press alpha B. Okay, you should do the similar thing for the second line. And I'm going to go to the third line. So we want alpha B minus alpha N. That's the log button. Times. Now we need the int function. So that's math. And we press right to go to num. And that's the fifth function. So we can press 5 or scroll down. I'll press 5. And then it's just alpha B divided by n. So that's alpha n. And bracket. And this is the store button. So the store button's here. And then alpha A. And then enter. Now you need the display function. So that's the program key again. And again, it's I/O. I/O means input output. And display is number 3. And then you can do the same alphanumerics to enter the last bit. Okay, once you've entered your program, it's automatically saved. So we'll do this example. So to run the program, you press program, scroll down to wherever mod is, and then press enter. So B is negative 8 over 3, as in our example. Make sure you put the negative sign rather than the minus sign. Negative 8 divided by 3. N is 2 because we have 2 pi. And we get 1.333. To convert this to a fraction, we press math and enter. And enter one more time, and we get 4/3. Okay, so that's the answer that we produced, and that's in the principal angle. Let's run this with 148 over 3. So we press program, we run mod, enter, 148 divided by 3, and 2 is what we're modding with. And then again, math, fraction, enter, enter, and we get 4 over 3. So it's not mandatory to enter this program, but I think it'll make your life more convenient. Okay, and just a few notes. 4 pi over 3 is in the third quadrant, so we subtract pi. So pi over 3 is our reference angle. And in quadrant 3, only tan is positive. So to find our 6 trig ratios, sine 4 pi over 3 is negative root 3 divided by 2. Cosine 4 pi over 3 is negative 1/2. Tangent of 4 pi over 3 is root 3. And I'm not going to read off this. This is cosecant, secant, and cotangent. And we're on our last page. We have a degree example. So 2010 degrees, you can use the modulus function or you can keep subtracting 360. I'm going to run the program. I'm going to enter 2010 and I'm going to enter 360. And we get 210 degrees. I'm going to run the program again. If the program was your last command, all you have to do is hit enter and it'll just run it again. So again, use the negative sign, not the minus sign. Otherwise you'll get an error. Negative 570. And we're in degrees, so we enter 360 as the modulus. And we get 150 degrees. Another type of problem that we're going to run into is area of a sector. This is the formula. The formula works because this angle is a fraction of the whole circle, and the whole circle is 2 pi. And this is just the area of the circle. So the area is 2 pi over 3. This is our angle, and we divide that by 2 pi. And we multiply that by pi r squared. Since we haven't specified a radius, we can just assume r. This cancels out with this, so we have 1/3 pi r squared. Last type of problem. If we're given angular velocity, then the distance, or we can use s as the arc length, is angular velocity times the radius times time, and this is in radians. Okay, so how far does a 30 centimeter diameter wheel travel in 25 seconds when rotating at 100 RPMs? So note that some information is indirect, and that would be the radius. The radius is the diameter divided by 2, so we have 30 over 2 centimeters, and that's 15 centimeters. Now, the angular velocity is 100 revolutions per minute. We have a question that's asking for 25 seconds. So we need to multiply this by 1 minute equals 60 seconds. And we also need to multiply this as 2 pi radians per revolution. Remember, revolution means once around the circle. So now we can cancel out revolution, we can cancel out minutes, and we're left with radians per second. Again, this needs to be in radians per second, or some time unit. So we have 100 times 2 pi. So this is 200 pi over 60 seconds. And that's radian. And we simplify. This is 10 pi over 3 radians per second. Time equals 25 seconds. So S equals 10 pi over 3 radians per second times 15 centimeters times 25 seconds. We can cancel out seconds. And radians is unitless. So we have another thing that we can cancel out. We can cancel out 15 and 3 with a 5 and a 1. So 5 times 25 is 125. So this gives us 1250 pi centimeters. This is an exact answer, so we'd like to leave it in this form, but we would like to know the approximate value. And if we put it in our calculator, we would find that this is approximately 3.93 meters. And that completes this lesson.